Hey everybody, it's Mr. Johnston. I'm going to go over the materials that we went over today, September 11th, 2020. All right, so today you should be able to recognize and categorize different subsets or groups of real numbers proven by correctly scoring 70% on an exit ticket. Just a brief review. We know that we have natural numbers, which are your counting numbers, and they start with 1, 2, 3, 4, go on to infinity. Whole numbers are your natural numbers, your counting numbers, but you add 0 in there. Now you start at 0. Integers are your natural and your whole numbers, so they're your counting numbers, including 0, but also your negatives, so the opposite of your positive natural numbers, right? So you have 0, 1, 2, 3. Now you include -1, -2, -3. You got your rationals, which are going to be all numbers that can be expressed as a fraction. This also includes percents and two types of decimals, decimals that terminate and decimals that repeat. Here's a couple examples. This would be a decimal that repeats. A terminating decimal would be something as basic as 0.5, right? There's nothing here, nothing left. All right. We also noticed yesterday that this is square root of 81. Maybe this isn't the best place for the square root of 81, right? Because square root of 81 is a perfect square. You can put that in a Desmos, and it'll equal 9. We see that 9 is actually a natural number. We've got over here your irrational numbers. Hopefully you can see that. Get my big head out of the way. Irrational numbers, which are going to be any non-repeating number that can't be expressed as a fraction. So, like I said, you're going to have your non-perfect square roots. If you plug this into Desmos, you're going to get something along the lines of 6 point something with a bunch of numbers after here. I don't know what they are off the top of my head, but they're there. Pi, we know that that's 3.14, and that goes on for forever. And then we have this gargantuan number here. Well, it's a small number, it's only 7, but it's a long number. And then it's got dot, dot, dot at the end. Remember, we called these the cray-cray dots, and they go into their own island. They go over here to the international, to the irrational island, the cray-cray dots. So once you hear that, bam, you know that those are going to be irrational. All right, get rid of. All right, so here's the same diagram. I just got rid of all the colorful stuff. What I'm going to do is we're going to do this trick. And you can see here, I'm going to draw this arrow. Because we know from the song that we heard in class that a natural number is a whole number. So, and a whole number is an integer, and an integer is a rational number. So a natural number is a whole number, a natural number is an integer, and a natural number is also rational. A whole number is an integer, a whole number is also rational. An integer is also rational. But all rationals are not integers. All integers are not whole numbers, and all whole numbers are not natural. So the flow is this way. You're going to go up. You can also have never write in red, right? So your flow is going to be up. That's what you want. So I'm going to do a couple questions real quick. So all natural numbers are integers. All natural numbers are integers. So I'm going to start here at natural, and I'm going to go to integers. As you can see, I'm going up. So this is going to be true. I start here at n, and I go up to integers. I don't know why I went all the way to rational, but the integers. So when we go to this one, true. All integers are irrational numbers. I've got integers here and irrational numbers over here. Well, we can't do this because we have this wall right here, right? And it's on its own island. So you can't just hop onto the island. That doesn't work. Irrational numbers don't play nice with the other numbers. So this one's definitely going to be false. All right, then we have all rational numbers are whole numbers. All rational numbers, oh, that was dumb. All rational numbers are whole numbers. We have rational starting here, going to whole. Looks like we're going down, right? Remember, if you're going down, the flow is supposed to be this way. We're going from rational to whole. It means you're going down. So this is going to be false. All whole numbers are natural numbers. We start here at whole, we go to natural, it's going down again. Whole to natural, it's going down. That means that it is going to be, oops, those are the answers, going to be false. All right, all irrational numbers are integers. Is that what I said? All irrational numbers are integers. Again, irrational, trying to get over here to integers. Nope, can't do that. You're over here by yourself, bud. These four play nice, not you. So this one's definitely always going to be false. All whole numbers are integers. All whole numbers are integers. We're going to start here at whole, go to integers. There we go. We got an arrow going up. So that is going to be true. All rational numbers are irrational numbers. All rational numbers are irrational numbers. I'm not even going to show you this on the slide. We know that irrational numbers don't play nice with the other ones. So that's false. All right. Let me erase this. Do a couple more. Give you a tricky one. And then we'll start something new. Let me move this slide down a little bit. All right. There we go. We've got all whole numbers are rational. Whole numbers going to rational, arrows going up. True. All integers are rational numbers. Starting at integers going up. True. Then we got all whole numbers are irrational numbers. Whole numbers to irrational. No. Once you see this irrational, it's not always going to be false, but when it's irrational numbers with other numbers, remember, they don't play well nice together. All right, we've got all natural numbers are rational numbers. All natural numbers are rational numbers. That's going to be true. We got all integers are natural numbers. Integers coming down to natural. Integers coming down to natural. It's going to be false, right? Remember, the way the arrow goes. I know I'm going through this a little quick, but we had an hour today in class going over it, so you guys can always pause and rewind. All irrational numbers are whole numbers. Bam, here's that red flag. When you see an irrational in here, you want to think it's with another, which is with, oh my goodness, it's with whole numbers. So it's definitely false. All integers are whole numbers. We'll come here and go to integers, whole numbers, integers, whole numbers, going down. That's definitely going to be false. You know, I wish I had this trick when I was in school. How about a little bonus question? All irrational numbers are real. True, false. Now remember, every number that I show you is going to be real. I don't have the power to make fake numbers. So that's going to be true. All right? So every number that you see right here, no, it's all covered up. Every number that you see right here, all these numbers are real. Natural numbers are real, whole numbers are real, integers are real, rationals are real, irrationals are real. Okay? I'm not going to make up fake numbers for you. All right, on to something new. This is just kind of some interesting lingo, but it's pretty helpful. So this is going to be your good oranges. So if you have a good orange and a good orange plus 4 multiplied, it's going to equal a good orange. Two good oranges always make a good orange. And what a good orange is a rational number, right? Rational number, rational. So if you have 2 good oranges, it gives you a good orange. If you have 2 rational numbers, it gives you a good orange. Now, if you have one bad orange, that'll turn all the oranges bad. So here's your bad orange and your good orange. It's going to give you a bad orange, whether you add or multiply. Remember, adding, I won't write it, but adding is a sum, multiplying is a product. And your bad orange is going to be your irrational number. Your good number, your good orange is your rational, but either way, it's always going to yield a bad orange or an irrational number. So there's 4 examples for you. What I've got here are the product of 2 rational numbers is going to be rational, right? This is your good orange. This is another good orange. They're going to give you a good orange. Just remember that they are rational. Times is going to give you a rational. All right, so 3.14 we know is rational because it's a decimal and it stops. Right? So that's a rational number. -7 is a negative number, a negative whole number. So that means that it's an integer, -7, and we know that integers are rational numbers. Oops. Sorry about that. All right. We've got another example. This is when you've got the sum of 2 rational numbers is going to be a rational number. Again, you've got your good orange and your good orange, and that's going to equal a good orange. Now you have to remember that good oranges are rational numbers. So your rational numbers are going to equal rational numbers when they are added, right? And you want to make sure you look at them. We know that 25 is a counting number, which makes it a natural number. And we know that natural numbers are rational. We also see this decimal here. You've got 5.16. 6 got a bar over it, which means that it's repeating. We know that repeating decimals are rational. Okay? So remember, good oranges plus or times another good orange equals a good orange, which is the same as saying a rational plus or times a rational equals a rational. All right? Now we've got the product of a rational and an irrational. That's going to give you an irrational. When they mix, they're going to give you an irrational number. When you have a rational and irrational times each other, they give you an irrational number. The thing here is you have to be able to figure out which one's your irrational number. So going from left to right, because it's the way we read, I would say, just look at it. Square root of 30. Is this a perfect square? No. If you're not confident in that, put it in Desmos or a calculator, right? But this is definitely going to be your bad orange. So this is the irrational one. This decimal right here, 2.147, stops. It's a terminating decimal. So we know that this is a good orange or rational number, right? And that's always going to, and that's going to equal an irrational number. And remember, a bad and a good orange, one bad one makes the rest of the batch bad. All right, and last one is the sum, now we're adding, of a rational number and an irrational number gives you an irrational number. Just like the previous one, the thing here is to look for which one is irrational, right? Because we know if they're both rational, then it's going to be a rational answer. So I come left to right, because it's the way I read. I see a fraction here. I know if it can be written as a fraction, it's definitely a good orange. So I've got rational numbers. I come over here, I try to do the square root of 15. I know it's not a perfect square. If you don't believe me, pop it in your calculator. But that's going to be your bad orange. That's a bag. Sorry, bad orange. And this is going to be irrational, right? And when you equal that, you're going to get a bad orange. Good orange plus a bad orange, always going to give you a bad orange. Rational plus irrational, always going to give you irrational. it's almost like irrational kind of like dominates the situation and takes it over. So that's pretty much what we went over today. I hope you guys all have a great weekend. I appreciate you guys coming to class. And I'll see you on Monday. Thanks.